Welcome back to another video. Today we're going to be talking about infinite series. This video will talk about both infinite arithmetic series and infinite geometric series. Now let's talk about what infinite means again. I'm going to pull up our old notes that we talked about a few weeks ago. And in this little chart you can see that finite stops versus infinite keeps going on forever and ever and ever. So far we have talked about finite arithmetic and finite geometric. So today we're going to talk about infinite series. So what happens when they keep going on forever? So for arithmetic series, the sum of an infinite arithmetic sequence is either positive infinity if d is greater than 0, or negative infinity if d is less than 0. So just to review, remember that d is the common difference. And to find the common difference, all you need to do is subtract the second term from the first term. Okay, if d is less than 0, then you're going to go to negative infinity. So this is pretty simple because you only have two possible answers. So it's either positive infinity or negative infinity, and that's it. There's not going to be an actual number. There's no formula. There's nothing you need to do. All you need to figure out what is the common difference, and if the common difference is greater than or less than 0, then you're either going towards positive or negative infinity. So let me give you an example. So let's say I start with negative 100, okay? And let's say my common difference is positive 1. If I'm adding 1, my next number will be negative 99. If I add 1, my next number will be negative 98. If I add another 1, my number will be negative 97. Well, I can keep going, adding 1, adding 1, adding 1. Eventually, I'm going to get to 0, then 1, then 2, then 3. And I can keep going. Eventually, I get to 10, 11. I can keep going. I get to 100, 101, 102, 103. And this will just keep going, and I'll keep adding 1 over and over and over again. Because remember, this series is infinite. It's not going to stop. So I'm going to keep adding 1 forever. And so essentially, this is going to go towards positive infinity. So if you're adding a number, you're going to go towards positive infinity. Now let me show you what happens if you're subtracting a number. Let me move this up a little bit. I took up a little bit too much space. Okay. Here's another example. Let's say I started at positive 300. And let's say I wanted to subtract 1 this time. Minus 1 would put me at 299. Minus 1 again would put me at 298. Minus 1 would put me at 297. And then it would be the same thing. I'm going to keep subtracting 1. I'll end up at 100. I'll keep subtracting 1, 99, 98. I'll keep subtracting. I'll end up at 50, 49, 48. Keep subtracting. I'll end up at 0. I end up at negative 1, negative 2. Because keep in mind, I'm still subtracting 1, minus 1, minus 1, minus 1. And I'll keep going. I'll eventually end up at negative 100, etc., etc. But as you can see, it's just going to keep getting bigger and bigger and towards the negative side. Okay, so the rule here is if you're adding a number and your common difference is greater than 0, so you're adding a number, you're going to go towards positive infinity. If you're subtracting a number, you're going to go towards negative infinity. And those are your only options. Alright, moving on to geometric series. So if the absolute value of r is greater than 1, then the infinite geometric series has no sum. Now what does that even mean? That just means the sum does not exist. Now we abbreviate does not exist as just D and E, so you don't have to always keep rewriting does not exist. But if you take the absolute value of the common ratio and it ends up being greater than 1, then you're done. That means there is no sum. And then just to recap the common ratio in case you forgot. The common ratio, you find that by dividing the second term by the first term. Okay. Now, if your common ratio is less than 1, then it does have a sum, and you're going to use this formula right below here. So the sum S of an infinite geometric series for which the absolute value of R is less than 1 is given by S equals A sub 1 over 1 minus R. Now, this formula is in your formula chart. I have it highlighted here under the sequence and series. And you can find here it says infinite geometric series. Now they don't have the arithmetic infinite arithmetic series, because that's something that you're gonna have to know on your own, that if it's going towards positive or negative infinity. But they do give you the formula for the infinite geometric series if it exists. So they're also expecting you to remember that if it is greater than 1, you need to know that there's no sum. So they're not giving you this, and they're not giving you this. All they're gonna give you is this right here. So those are still 3 things that you need to remember on your own. But this formula is on your formula chart, like I said, right here. So A sub 1 over 1 minus R. And the good thing is they at least kind of give you a hint on your formula chart that you only can use this when the absolute value of R is less than 1. When the absolute value of R is less than 1. Okay? So the formula for the sum of an infinite geometric series involves 3 variables, S, A sub 1, and R. If you know any of the 2 variables, you can always solve for the third one. So sometimes they might give you the sum in the first term. They want you to figure out the common ratio, or they give you the first term and the ratio, and they want you to find the sum, or whatever combination of things they want you to do. But they might ask you to do different things, and then you would just do algebra to solve for the other variable. So now how are you going to know when it's infinite versus finite? So finite series, they're either going to give you the last term, or they're going to tell you how many total number of terms there are. So remember, they give you the last term. It might look like this: 3, 6, 12, dot, 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 I don't know, random number, right? And then it stops right there, and then whatever that last one is your last term, A sub n, and this one is A sub 1, the first term. So that's finite when it stops and they give you the last term, or they might say find the find the first 6 terms of the sequence, right? So they say how many total number of terms there are, then that would be finite. Now, if it's infinite, they don't necessarily have to tell you that it's infinite, but as you can see in these examples, we don't have the last term, but we also don't know how many total number of terms there are. It just says find the sum. Let's say the infinite word was not here and it just said find the sum. Well, we don't know how many terms there are, and we don't know the last term, so that would be a clue that it would be infinite. Another clue, if it's written in sigma notation, if your upper bound is going towards infinity, that is a clear indicator that it's an infinite series and not a finite series. Okay, so usually finite would have like a number here, like, so let's say like from 4 to 10, that would be finite because it has a stopping point. Okay, but if it's infinite, it'll have infinity at the top and it'll keep going, no last term. They won't tell you how many terms there are. Okay, so let's do some examples. So first, let's find the common ratio. So remember, we're going to divide the second term by the first term. So the second term being 3, first term being 9, that gives you 1/3. Then you divide the third term by the second term, so 1 divided by 3, and you can see that the common ratio is going to be 1/3. Okay, so these are all being multiplied by 1/3. So that's the common ratio. Now, oh, I forgot to say something important. So the absolute value, in case you need a refresher, the absolute value makes everything positive. Okay, so think about it like a car wash. When you take a dirty car through a car wash, it comes out clean. When you take a clean car through a car wash, it's still going to come out clean. So it doesn't matter how you go into the car wash, the car will always come out clean. So it's the same thing for the absolute value. You can go in positive. So the absolute value of positive 5, you're still going to come out positive. If it's the absolute value of negative 5, it's still going to come out positive. Okay, so it doesn't matter whether you're positive or negative originally. If you're taking the absolute value, it'll always be positive. Okay, now for the formula, so there's always some confusion. This rule only applies to figure out whether or not there's going to be a sum or not. But in terms of this R that's going into the formula, this R is what your common ratio was before you took the absolute value of it. So let's make a note because some kids always forget that, and I don't want that to happen to you. Okay, so the R you plug in is the R before you take the absolute value. Okay, because for all of these problems, you're going to have to take the absolute value of R, but that is just to test whether or not there is a sum or not. After that, you're going to go back to your regular R that you calculated. Okay, so we're going to test the absolute value of R. So the absolute value of R is 1/3. So I'm going to take the absolute value of 1/3. Well, the absolute value makes everything positive. So my absolute value of R is just going to be 1/3. Now, the rule is either greater than or less than 1. 1/3 is less than 1. So if the absolute value of R is less than 1, then there is a sum. Okay, so I'm going to say therefore. Remember, these 3 little dots means therefore the sum exists. Okay, now we're done with that absolute value of R thing. All that gave us was the fact that there was a sum and that we're going to use the formula S equals A sub 1 over 1 minus R. Okay, now the first term is the first term here. I'm just going to label it. A sub 1 is 9. Okay, so the formula S equals A sub 1 over 1 minus R. A sub 1 being 9, 1 minus 1/3. And I'm going to put that into the calculator. 9 over 1 minus 1/3 is 27 over 2. Okay, and so that's the sum of the infinite geometric series. All right, let's try number 2. So we'll start out by finding the common ratio. I'm going to divide the second term by the first term. So negative 1.25 divided by 0.25, I get negative 5. I'm going to divide the third one by the second one, and I get negative 5. So that means these numbers are being multiplied by negative 5 every time. So I'm going to do the test to figure out whether or not there is a sum. So I'm going to start by taking the absolute value of R. The ratio is negative 5. I'll put that in the absolute value symbol. Remember, anything that's negative is always going to come out positive. So the absolute value of negative 5 is just positive 5. Now the rule is it greater than or less than 1? Okay, 5 is greater than 1. Now, if it's greater than 1, if R, the absolute value of R is greater than 1, then the geometric series has no sum. Okay, so I'm going to say now the sum does not exist. And if that happens, that's pretty simple because now you're done because there's nothing for you to do if the sum does not exist. Okay, let's go on to number 3. So again, here's another indicator that you're going to have an infinite series because it's going towards positive infinity. Remember that everything in the parentheses right here is always going to be your common ratio. So you're going to take the absolute value of r, which is 0.2. All the absolute value does is make the value positive. So the absolute value of 0.2 is just 0.2. Now, is it greater than or less than 1? Well, 0.2 is less than 1. If it's less than 1, that means the sum exists. Okay, so now that we know the sum exists, we're going to figure out what the first term is and then use the formula. Now remember from the last video, to find the sum, not to find the sum, to find the first term, you plug the lower bound into n. So to find the first term, we're going to do 4 times 0.2 to the power of 4 minus 1. Okay, and I'm putting that in there, and then I'll put that in the calculator. 4 times 0.2 to the power of 4 minus 1. So I get 0.032. Okay, and now we use the formula. So S equals A sub 1 over 1 minus R. A sub 1 is 0.032. R is 0.2. Okay, now I'll put this into the calculator. So 0.032 over 1 minus 0.2, and we get 0.04. Alright, let's do some more examples. So we're going to start by finding the common ratio. So we're going to divide the second term, -5, by the first term, +10. We get -1/2. We're going to do that again with the third term. Divide that by the second term. We get -1/2. It came out as a decimal, but they're both -1/2. Okay, so this time we're multiplying by -1/2. So we're going to take the absolute value of r to test whether or not there's going to be a sum. So I'm going to do the absolute value of -1/2. Well, I'm going to take the absolute value of it, meaning it's going to end up being +1/2. And to do the test, you figure out whether it's greater than or less than 1. 1/2 is less than 1. So that means there's going to be a sum. So therefore, the sum exists. Okay, now identify what the first term is. That's the first term in the series, so it's just 10. And then you can just plug everything into the formula. Okay, so 10 over 1 minus 1/2. Put that in the calculator. 10 over 1 minus 1/2. And, oh, I think I messed up. Yes, I did. I did what all the students do all the time. Whoops. So you have to use your rate before you take the absolute value of it. So I put this +1/2 in there. You don't use this absolute value of r in this formula, you use this one. Okay, so this is r. So it's going to be minus -1/2 because the ratio was -1/2. So 1 minus the ratio, 1 minus -1/2. So 1 minus -1/2. There we go. So the answer is 20 over 3. Okay. So yeah, just be mindful to not make the same mistake that I made. So once you're done with this, don't look at this anymore. Okay, this is the ratio that's gonna go into your formula. That's why it was important that you made this note above. If you haven't, go back and write it because it's very easy to make that mistake. All right. So 20 plus 15 plus 10. Okay, let's see. 15 divided by 20, 3/4. 10 divided by 15, 2/3. I guess it's not geometric, so let's see if it's arithmetic. So 15 minus 20 is -5. 10 minus 15 is -5. So every time we're subtracting 5. That was pretty easy to see, but just in case you couldn't see it, I wanted to show you. Okay, so we're subtracting 5, subtracting 5. If we keep subtracting 5, we're going to end up at 5, 0, -5, -10. And the numbers are just going to keep growing and growing in the negative direction, -10, -15, -20, etc., 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 until it reaches negative infinity. Okay, because it's just going to keep growing in the negative direction. Okay, so this is an arithmetic series where the common difference is -5. Now remember, for arithmetic series, you have two options. If your common difference is less than 0 or greater than 0. So ours was -5, meaning it is less than 0. So that means the sum is negative infinity. Okay, so the common difference is -5, which is less than 0. So the sum is negative infinity. And that's it. Okay, let's do one more. So here we have another series written in sigma notation. Remember that your common ratio is the one that's in parentheses. So you start by taking the rate, the absolute value of the ratio. So the absolute value of 0.8 is positive 0.8, which is less than 1. Therefore, the sum exists. We're going to figure out what the first term is by plugging the lower bound into n. So that'll be 120 times 0.8 to the power of 1 minus 1. We'll put that in the calculator. 120 times 0.8 to the power of 1 minus 1 is still 120. And now we can use the formula. Okay, 120 over 1 minus 0.8 is 600. Okay, so the following page, I want you to try by yourself. There are 5 problems there. So just to recap again, if it's arithmetic and there's a common difference, if you're always adding a number, it's going towards positive infinity. If you're always subtracting a number, it's going to go towards negative infinity. For a geometric series, if after you take the absolute value of r, it ends up being greater than 1, then there will be no sum. The sum does not exist. If the absolute value of r is less than 1, then there is a sum, and you're going to use the formula s equals a sub 1 over 1 minus r. Reminder that you don't use the r that you took the absolute value of. You're always going to use the one that you calculated from the terms of the series. And yeah, I hope you learned something. Let me know if you have any questions, and I'll see you guys in the next video. Bye.